I know FX for my math questions, so
Can
that's
you
it.
turn off annotate?
Oh, I think only coach. Let me go back and ask Matthew. Give me 1 second.
Sure. In the meantime, I just want to know like which grade are you from? Can you type that in the chat? Just out of curiosity. Yeah. So we have contest math and the fast track stream.
Hello, screen share. Advanced sharing options. View options. All right. Annotate. I I don't know how to disable. Wait.
I bet that's Xiao annotating.
Probably. All right. I don't. Jerry, is Jerry here? Elaine, I don't actually. I'm not actually able to disable annotations. It might have to be you guys. Who's sharing right now?
Xiao? Oh
Xiao.
my
Xiao might
god,
have to
he's
disable.
annotating himself.
Xiao, you might have to turn off the annotations yourself if there's a button. Try that, please. Thank you. I'm gonna go back. Jerry, I think Xiao has to turn them off. The guy who's sharing. I
Oh,
can't
the
do it.
person who's sharing? Oh,
Yeah, I can't do it. I don't know.
okay. It's okay. There's one person left in the breakout. We can go back.
All right.
Okay. Uh,
How do I join the? Oh, I leave
Wait,
there.
Shao,
Okay.
can
I
you
guess.
turn off annotations? Shao. If you go to view options, or maybe I think a host can do it. Otherwise, I think you go to
No,
options.
start here. Start
Oh,
here.
it starts here. Yay.
Sounds gonna
Goodbye.
All
Bye.
right, cool.
Oh my god.
All right. I think we can start unless there are any objections to starting.
Okay, great.
Cool.
Okay.
Shao, can you?
Oh my god.
Can you? Thanks.
Okay,
Cool.
great.
Great.
Do you want? Okay, I can start. So, hello everyone. Welcome to Functions, and this is our first curriculum stream lesson, and you'll be learning about functions. So first of all, why should you do curriculum math? So we didn't mention it in the last meeting because we weren't sure about which stream we're gonna do, but it builds a strong understanding for future courses if you're planning to take functions, advanced functions, calculus, or even AP calculus. So it helps you to learn ahead of the others if you wanna be the smart and cool kid in your class. So you'll be able to understand harder concepts with a strong foundation. And also it is highly recommended for students in grade 9 to 11 if you haven't taken functions yet. So first of all, we're going to begin with intro to functions, and then Jerry's going to do a lesson on inverse functions. Oh my god, it's annotation. Okay, so number one, let's begin with defining some vocabs. So first of all, what is domain? Domain is the set of all values of the independent variable of a relation, and range is the opposite, is the set of all values of the dependent variable of relation. So as you can see here, these are the notations for domain and range. So XER equal is it means X is in all real numbers, and between this number and that number, as you can see. So range means Y is in all real numbers and between a value and another value. So a relation and function. So a relation is a set of ordered pairs. Its values of the independent variable are paired with values of the dependent variable. So and a function is a relation where each value of the independent variable corresponds with but I just wanted to mention that all functions are relations, but not all relations are functions. It is similar to the concept where squares and rectangles, right? So square is always rectangles, but rectangles are not always squares. can always go check out our YouTube. Oh my god.
I think it's technical difficulties. Don't worry about it.
Okay.
Be back in a second.
Oh, hey, it's back.
Yay. All right. We can continue now that it's back.
Okay. Oh my god, it's his Wi-Fi. Okay. So for functions, you can think of it as a machine. So this is the input machine, and that one is the output machine. Okay, so first of all, we know that in grade 9 and 10, you used to write f at x as y. So y is equal to something, something. But for this one, f at x is read as f at x or f of x in grade 11 and 12, or even higher grades. So f of a represents the value or output of the function. Can substitute a for x in the equation for f of x. So it sounds really complicated, but it really is not. So if you look at this machine, the input and output machine, so if you input a equals to 2, for output, you will get f of a equals to f of 2 for the output. So because you would just simply sub in a equals to 2, right? So it's really simple. So now I'm going to introduce you to the vertical line test. So if you have graphs of functions, how do you know that? Sorry, if you have graphs of relations, how do you know that which one is a function and which one's a relation, right? So for a function, each y only has one x, but for each x, it can have multiple y's. So for example, the vertical line test, if you apply it, it basically means, yes, it is grade 11. So it basically means if any vertical line intersects the graph of a relation more than once, then the relation is not a function. So if you apply the vertical line test on the first example we have here, as you can see here, the graph only passes through the vertical line once. It is almost at -3 and -1. So it passes through the graph once, so it passes the vertical line test. Therefore, it is a function. And if you look at the second example, it is actually an inversive function, which Jerry will be talking about later. So as you can see here, yeah, there are 2 points of intersections. So therefore, it failed the vertical line test, and it is not a function. So here we've got some examples for you. Oh my God. Can you, oh my God, because you downloaded this site. Okay, there was supposed to be animation, but okay. So I'll just explain those. So the first one is a circle. So as you can see here, it passes through the vertical line twice, 1, 2, right? So therefore it failed the vertical line test and it is not a function. And for a second example, no matter which way the parabola is facing towards, so this one's downwards, but it also can be upwards, it doesn't really matter. So it passes through the vertical line test because it only intersects the vertical line once. Okay, so it is a function. Shao, can you adjust the screen a bit because I wasn't gonna post the answers.
Wait, Elaine, do you want to share your screen instead?
Okay, sure.
Because I think it has animations on your screen.
Yeah, I do.
Okay,
Sorry, give me a second.
cool.
Can you all see my screen here?
Yep.
Okay, good. Let me just okay, here. So these examples we already talked about. Okay, so do you want to try this out? Remember the input and output machine I've mentioned earlier? So first of all, can you try this example with, for the function f at x is equal to 2x minus 5, determine, first of all, f of 2 plus f of 1. If you have the answer, feel free to unmute yourself and tell us the answer, or type in the chat so we'll take it up. If you already have the answer, we'll give it a few minutes for the others to input their answers, and you can start working on the second one. Okay, so there's a lot of answers in the chat. So yes, the first one is negative 4. Can you press, sorry, it's me. Okay. Okay, so you would sub in 2 for x and 1 for this x. So you would minus both of these equations, and then you would get 4 minus 5 plus 2 minus 5, negative 1 plus negative 3, and you would get negative 4. For the second equation, I'll also take it up. It's quite different because you wouldn't plug 3 into x this time because f at x itself equals to 3. So it would be equal to 3 equals to 2x minus 5, and then you would get 8 equals 2x and x equals to 4. Okay, so here comes our third example. This actually is a thinking question that was from previous tests. So sketch a relation that is not a function that has a set of all real numbers less or equal to 10 as its domain and all real numbers greater than negative 5 as its range. So remember the function notation, the domain and range notation I was talking about. Yeah. So you would try sketching a graph following these instructions. So just a hint, it wouldn't be a circle. I don't know how you can answer this question in the chat, but you can give me some ideas. All right, so I guess if there is no more input here, I'll take up the question. So first of all, we will draw a conclusion on the domain and range for this question. So x, as in the question mentioned, x is in all real numbers and less or equal to 10, right? So y is in all real numbers, but y cannot be equal to -5. It can be only greater than -5. So if you draw the graph, it would look like this. Don't judge my drawing. It was ugly. So as you can see here, there's a dotted line on -5 here because it is a horizontal asymptote. So I will just quickly explain what a horizontal asymptote is. It is when a graph approaches, it continuously approaches -5, but it never touches the -5 axis. So it can be -4.9999, but cannot be -5. Yeah, and that's how the graph would look like. And this would be a typical thinking questions on your functions test. Actually have one more slide, Jerry. So here, 2 more questions. So these are pretty challenging domain and range questions. Sorry, I don't know, Jerry, do you want to explain that or I can go? Or should we give them a few minutes to solve these questions? Okay. I'll give you a few minutes to solve these hard domain and range questions and we'll take them up. Yep, domain is basically X and range is Y. Maybe I'll wait for like a few minutes, and if you don't have any input, I'll just take up the question. Yes, t cannot be equal to 2, but there are 2 more answers for question 1. That's right, t cannot be equal to 2 and 0, and there's 1 more. Awesome, so we've got all 3. So t cannot be equal to, so the range would be t cannot be equal to 0, 4/3, and 2. Because as you all know, the denominator of the fraction cannot be equal to 0, or else there will be a hole in the graph, right? So if you find the common denominator of this function, you will get if you set this denominator as 0, you will get t equals to 0, 4/3, and 2. Therefore, the range cannot be, therefore t cannot be these numbers. And if you want, you can try the second one. I think this one's a pretty easy one. So I think since we're running out of time here, so I'll just quickly take this question up. So if you actually plug in, this is how I do it. If you plug in 4 to the x, you will get 7. And if you plug in 9 into x, you will get 9. So therefore, p of x has to be greater or equal to 7, but less or equal to 9.
To add something to that, you also have to verify that all of the possible values between 7 and 9 are possible to be attained. So if you actually write out what px is compared to x, you see that square root x is continuous, which means that it exists at 7 to 9. So px should also. So it exists at 7 to 9.
Right. Okay, so there are some important things that you need to know when you're sketching about functions. So first of all, not all functions are defined everywhere. So as I've mentioned earlier, the denominator cannot be equal to 0. If a equals to 0, the functions may have holes where these values are not defined. So for example, f at x equal to x squared over x and f at x equals to x are not the same graph because the former is not defined by defined at x equals 0. And if you're interested, you can always verify that on Desmos. Okay, I will let you share screen, Jerry. Okay, I think since we're kind of running out of time and we have to go back to the main room at 3:25, we'll just end here, and hopefully Jerry can do the next part of the lesson next week. So be sure to join us next week and we'll take up the other part of functions. I will stop sharing my screen. And we'll be posting the slide on Classroom later.
Yeah. Shao, the answer to your question is yes, but not everyone necessarily might be able to come to Markomath. So if we do it, some people might miss out. We can also record, we can talk about it later. So if you want to hear the second half of the lesson like today, you can come to Markomath. And then if we have enough like engagement there, we'll just finish the lesson there.
Yeah.
Yeah.
Okay, so our class for Pets Math is from 2:50 to 3:30. But we have to go back to the main room and meet the other half of the people at 2:25. So yeah, Zoom Meet for Markham Math will be posted on our Discord server. If you're interested in joining that, I can send you the Discord code. And if you don't have Discord, I guess I can just send the link to the Zoom meeting. Do
I'll
we have one?
spam the link, the Discord invite link in the chat. Oh, if you don't have Discord, that's fine. At the end of the meeting next time, we will post the Markomath link on the Zoom. We just can't post it on the Classroom because issues with stuff. I think it's this one, right? Wait, let me what is the Markomath Zoom? What's the Markomath Zoom link? Do you want to post that?
No teacher supervisor. So Markham Math will begin at 3:30 and hopefully.
Wait, Elaine, do you want to post the Markomath link? Zoom link?
Zoom link?
Yeah.
I don't think we have one because we're already in meetings and we can't create one right now.
No, I mean like you can post the Markomath Zoom link here. Just post it. Because I don't know. I can't.
Did someone already create one?
I have no idea. Should I go back and I'm gonna go back and ask.
Yeah, we can bring them back. Matthew, are you done for the contest?
No, we're not done. So if they wanna check out the contest stream, go for it. If you wanna just move over, I'm not sure if you have the option.
So you can leave room and then you can join our
join the contest stream. Yeah, that one's still going. There are a few questions still going on there. We'll post the Zoom link later. I don't have.
Some people don't have Discord right now, so they like want the Zoom link to Markomath.
We'll put it on the Classroom. Is that okay?
Are we allowed to? Because it's not teacher supervised and it's sketchy. It's better if we just post it here.
I don't think we have a link for the.
I'll go Esther.
Okay, cool.
Yeah, okay.
But if you guys want to move over to the contest stream now, go for it. I'm gonna leave this room, move there too.
Yeah.
I'll be sitting in the main room, probably moving them over.
Okay, cool.